All right, welcome to the Explainer. Today, we are jumping right into something that sounds, well, just plain wrong. We're talking about elite sailing, where sometimes the longest way to the finish line is actually the fastest.
I mean, think about it. How can a longer path be the faster route? It doesn't make sense. If you're racing, you go straight. That's rule number one, right? Well, in the world of Olympic-class sailing, they kind of throw that rule book out the window.
And the answer, the secret sauce, if you will, is this incredibly cool technique called the S-turn. This is where you see that top sailors aren't just letting the wind push them around. No, they're actively sculpting the wind, basically turning their boat into this dynamic engine that makes its own power.
So, to really get our heads around this, we're going to dig into a super detailed computer simulation. This is all based on some PhD research from Cornell University. They actually put sensors all over a boat to capture every single tiny movement, creating this incredibly accurate virtual model. Pretty cool stuff.
So what they did was build this virtual sailing lab. Here, they could test out a bunch of different downwind sailing techniques side by side. This was the key, you know? It let them break down the S-turn piece by piece to figure out exactly where that amazing burst of speed was coming from.
Okay, and this is where it gets really interesting. Look at how they broke this down. You've got your control group, right? The baseline, just sailing straight. Then you have the full S-turn with that rhythmic rolling motion. But then, and this is the clever part, they tested the pieces separately. Just the S-turns, no rolling. And just the rolling, no S-turns. This is how you find the secret ingredient.
All right, so let's get to the good stuff, the results. When you actually measure the raw power pushing the boat forward, what sailors call the driving force, the numbers are, well, they're pretty mind-blowing.
So this is the million-dollar question, isn't it? Which one of these techniques actually creates the most oomph, the most pure power to shove that boat across the finish line?
And boom, here's your answer in glorious bar chart form. The perfect S-turn, the whole shebang. It isn't just a little bit better. It's in a completely different league compared to just sailing straight.
Just look at that number, 178%. Let that sink in. This technique nearly doubles the driving force from the sail. You're basically getting twice the power out of the exact same wind. How is that even possible?
And get this, the simulation coughed up another little surprise. It turns out that just doing the S-turns without any of that rolling motion was still more powerful than just rolling the boat on a straight course. That tells you that the carving motion itself is a massive piece of the puzzle.
Okay, so where in the world is all this extra power coming from? It feels like magic, but it's not. The secret isn't in the boat or the sail. It's in the invisible world of airflow that the sailor is actively shaping and controlling. The key, it turns out, is all about creating something called vortices. Think of them as these powerful, swirling pockets of air. By doing this rhythmic dance of turning and rolling, the sailor is basically conjuring up these temporary engines made of air that literally grab onto the sail and pull it forward.
And it's not just one big push. It's this 1-2 punch combo. First, as the boat turns up into the wind and rolls, a vortex forms along the mast. That's your first little push. But then, as the boat turns away and rolls back, a second, way more powerful vortex forms along the back edge of the sail. That's called a lead.
You know, the researchers had the perfect way to describe this. They called it a mini tornado forming from the end of the boom up along the leech. Just picture that. This swirling column of low-pressure air creates this massive suction force, literally vacuuming the sail and the whole boat forward.
And at its absolute peak, right at that moment that mini tornado is fully formed, the driving force can spike by a staggering 70%. 70! That's a massive, short burst of insane power that happens again and again and again with every single S-turn.
Okay, so physics is cool and all, but let's bring this back to the real world. What does all this force and talk of tornadoes actually mean in a race? You've got more power, sure, but does that actually make you win?
And this is probably the question you're asking right now. We saw a nearly 180% increase in power. So, does that mean the boat goes almost twice as fast? You'd think so, but the physics of sailing is a little trickier than that.
And here's the catch. As your boat goes faster, the wind you actually feel on the boat, sailors call it apparent wind, it actually gets weaker. It's a weird feedback loop, right? More force makes you go faster, but going faster reduces the force. It's this constant balancing act. So, to get to the bottom line, To find the real speed advantage, the researchers took all this data and plugged it into what's called a velocity prediction program, a VPP. You can think of it like this super smart calculator that balances all the forces, the push from the sail, the drag from the water, to figure out the boat's actual, real-world top speed.
And so, after all that complex calculation, balancing everything out, what did the VPP spit out? A real-world speed advantage of 0.6 knots, plus 0.6 knots.
Now, I know what you're thinking. 0.6 knots? That's nothing. And yeah, in a car, it's nothing. But in elite sailing, where every single boat is identical, oh, it's a massive game-changing difference. So what does that actually look like on the water?
And here it is, the big payoff. Over a pretty standard 12-minute downwind run in a race, that tiny 0.6 knot advantage adds up to a lead of over 200 meters. Let me say that again, over 200 meters. The sailor took a longer, wavier path and ended up an entire city block ahead.
So I'll leave you with this. In a sport that is often decided by mere inches, what could you do with a 200-meter head start? It just goes to show you, the best sailors aren't just reacting to the elements, they are actively bending the laws of physics to their will. It's not just sailing, it's something else entirely.